I'm a research mathematician and I'm going to walk you through this problem step by step, and watch till the end to really master sine theta, because I'm going to show you some tricks that help all over the place. So here we have 2 sine squared theta minus 9 sine theta minus 5 is equal to 0. So the first trick with these kinds of questions is just notice that this is a quadratic equation in sine theta. So what I mean by that is these two quantities, if we put x is equal to sine theta, then we can rewrite the equation as 2x squared minus 9x minus 5 is equal to 0. So then we're going to solve for x, and then we can figure out what theta needs to be to solve for theta in the equation here. And this is going to involve some subtleties. So first, to solve for x here, well, the basic trick here is to just say that we want to find two numbers a and b, so that their product AB is equal to the product of the two numbers here, the two coefficients 2 and minus 5, which is equal to minus 10, and we want their sum a plus b to be the middle coefficient minus 9. Okay, this is how we typically solve these or factor these quadratic equations, and we'll see how it factors. Okay, so once you've got this down, so we see that a equals minus 10 and b equals 1 works. Okay, so a equals minus 10 and b equals 1 works. So we're going to split up the middle term minus 9x as such. We're going to say this is 2x squared minus 10x plus x minus 5 is equal to 0. So notice I've got the a is a minus 10 and b is the 1, so I've sort of split it up that way. And now we can say this is 2x times x minus 5. Okay, so I'm going to factor the first half and factor the second half. Okay, typical factoring quadratics. So factor the first half, factor the second half. So 2x times x minus 5. Now I want to see an x minus 5 there, which I do. And then it's something silly. I'm going to multiply with 1. So 1 times x minus 5 is equal to 0. And the point being here that we can now factor an x minus 5 from both terms. So we can write this as 2x plus 1, 2x lots of x plus x minus 5 plus 1 lot of x minus 5 is 2x plus 1 lots of x minus 5. So 2x plus 1 times x minus 5 is equal to 0. And now we just need to solve for x. So we know that a product of two numbers cannot be 0 unless one of the two numbers is 0 at least. So we either have 2x plus 1 is equal to 0, so 2x plus 1 is equal to 0, or x minus 5 is equal to 0. So 2x plus 1 is equal to 0, well, x is going to be minus half. Okay, so we can basically do that way. So x is equal to minus half, or x is equal to 5. Okay, so minus half or 5 are the solutions, and now we know what the solutions are going to be for sine theta. So let's erase this and write that down that way. We could have also used a quadratic formula, whatever you like, okay, whatever you prefer. I've done it that way, but I just wanted to show you that way to master, because it's a bit more creative than the quadratic formula, so it's harder to apply. So we know x equals sine theta, we know it's going to equal to minus half, or it's going to equal to 5. Now, here's the thing, sine theta can never be greater than 1 or less than minus 1. It's always between minus 1 and 1. It's a fundamental principle. So we can rule out the 5. But what I'm going to do to show you, because this is a tricky part of solving these problems that a lot of students struggle with, okay? So I want to help you along with this to understand all the thetas so that it's equal to minus half, because there are infinitely many and we want to nail down every single one. So the method I like to do that's super intuitive, and I'm going to walk you through this, is the unit circle method, and we're going to make this very, very clear. So we draw the unit circle, and it's always helpful to remember the definition of sine and cosine. So the definition of sine and cosine is if I draw a segment here with an angle of theta, then this point on the unit circle has coordinates cosine theta and sine theta. The reason being that it's a unit circle, so the radius is 1, so this hypotenuse is 1 when you draw this right triangle, and so by definition cosine theta is going to be this length divided by the hypotenuse, which is 1, so cosine theta just, and then sine theta is going to be this length divided by the hypotenuse, which is 1, so this length is just going to be sine theta. Okay, so that's a way of looking at it. So when we want to find out when sine theta is minus half, I mean, first of all, you know the y coordinate, which is sine theta, can never be beyond 1 or minus 1, okay, because it's a unit circle, so this point has a y coordinate of 1, this point has a y coordinate of minus 1. So that's there, so we can sort of see the 5 cannot happen. But also for the minus half, well, we can sort of imagine that you want minus half, you want the y coordinate to be minus half, so you're looking at 2 points on the unit circle. And you've got to remember that aside from those 2 points, you can add on multiples of 2 pi and get solutions, because sine is defined on the entire number line. Okay, so we need to figure out what these angles are. Okay, what these angles are. So I'm going to sort of draw it like this. We want to figure out what angles these correspond to, and then we want to add on multiples of 2 pi, integer multiples of 2 pi. Okay, so let's do it on this side of the board to really see it visually. All right, so let's see it visually. So we can kind of visualize this as follows. So I find this very helpful to visualize, is we want to find out what are the points whose y coordinate is going to equal to minus half. Okay, so they're going to be 2 points, and we want to figure out what they are. Now, because it's minus half, that's where the trickiness comes in. It's always helpful to convert to positive numbers because we understand sine between 0 and 90. That's our frame of reference as human beings. So we want to think about when sine is equal to half, which is going to be the reflection in the x-axis. Okay, this is when sine is going to be half, or like this, okay, when sine is going to be half. So we need to figure out what angle measures are here and then take negative of them. Okay, so if this is going to be theta, this is going to be minus theta. Okay, so we just need to do that. So figure out when sine theta is half and then take negative of those two angles. Okay, so how do we do that? So for sine theta equals half, it's helpful to remember, so I'm just going to write it down this way. Sine theta is equal to half happens when theta is equal to 30 degrees or pi over 6 radians. Okay, so we're going to practice with radians. Pi is 180, so pi over 6 is 30. Okay, so pi over 6 is when sine theta is equal to half. But as you can see in this picture, this angle is also going to be symmetric. It's also going to be theta, okay, whatever it is. And then the complementary angle, which is basically how far you're subtending along from the positive x-axis, which is what this point is going to correspond to, is going to be pi, which is 180, minus theta. Okay, so pi minus pi over 6 is going to be the other solution. So theta equals pi minus pi over 6, which is going to be 6 pi over 6 minus pi over 6, which is 5 pi over 6. Okay, so we're going to get 5 pi over 6, and so we're going to have an angle there of 5 pi over 6 if you like. So this is going to correspond to 5 pi over 6, this is going to correspond to pi over 6. Now those are the two solutions, but then of course we have to take negative of them, because remember we're looking at when sine theta is minus half. This is also reflective in the identity. It's a trig identity that's very cool to know, is that sine of minus theta is equal to minus sine of theta. That's just saying that when you reflect in the x-axis, your y-coordinate flips sine. Okay, just think about that identity in the context of what we just did. And now we're going to write down all the solutions for theta, so let's do it on this side of the board. All right, so we know that sine theta is equal to half at pi over 6 and 5 pi over 6 radians. So when is sine theta going to equal to minus half? Well, sine theta is going to equal to minus half when theta is going to equal to either minus pi over 6 or it's going to equal to minus 5 pi over 6. Okay, those are going to be the cases where sine theta is going to equal to minus half. And now if you don't like, okay, so now the solutions, I'm going to write down the solutions. The general solution, because we're looking at theta across the number line, we're going to add on multiples of 2 pi. So it's going to be theta is minus pi over 6 plus 2 pi k, or minus 5 pi over 6 plus 2 pi k, okay, where k is an integer. Okay, so k is an integer. That means it could be negative 1, negative 2, negative 3, 0, 1, 2, 3, etc. Okay, in either negative or positive directions. And if you don't like, you know, the negative pi over 6 and the negative 5 pi over 6, if for example the question asks, find the solution in the interval 0, 2 pi, okay, then you know that adding on some multiple of 2 pi will bring these in to that range, okay, that range between 0 and 2 pi, because these two are negative. So you can just add on 2 pi to them, okay, if you like, if you want to see that. So minus pi over 6 plus 2 pi, minus pi over 6 plus 2 pi is going to equal to minus pi over 6 plus 12 pi over 6, which is 11 pi over 6. And similarly, minus 5 pi over 6 plus 2 pi is also going to equal to minus 5 pi over 6 plus 12 pi over 6, which is going to equal to 7 pi over 6. Okay, so 7 pi over 6. So you can kind of think about these angles. This is going to be corresponding to 11 pi over 6 radians as you subtend around the positive x-axis, and this is going to correspond to 7 pi over 6 radians. Okay, so those are going to be the solutions in the interval 0, 2 pi. I do a lot of trig on my channel, and you're going to love the next video, which is calculating sine of 36 degrees. Sine 30, we know. Sine of 36 degrees. How do you do that? It actually involves solving equations just like in this video. You're going to love it. Super popular video on my channel is going to pop up on the screen here. Or if you want to understand another cool thing, high-level university math, abstract algebra and group theory, in a way that a 5-year-old can understand, a new arithmetic operation you saw at the age of 5 but you never realized it, check this video out. Either of them you're going to love, and don't forget to hit that like button and subscribe for lots more fun math content. As you can see, I do it all